Hello guys, welcome to the DMS online school. In today's video, I want us to go through an examination question in chemistry coming from the topic known as atomic structure. Okay, so in today's lesson guys, we are going to look at a question coming from chemistry topic known as atomic structure. So without further ado, let's go straight into this revision. Okay, so this is supposed to be science paper 2 revision, and then we have question part A says complete the table below. Okay, so let's complete the table below. First of all, we have to look at this part here. We have seen this part. We are told that we have a symbol of an atom or ion. So in here, we are given the symbols of an atom or ion. Then in here, number of protons in one particle. So we are being given the number of protons in that particular atom or ion that we are provided here. Here, they are giving us the number of protons in that particular particle. Okay. Then here, number of electrons in one particle. Okay, number of electrons in one particle. So in here, we are supposed to put the number of electrons in one particle. Okay, so for you to be able to answer this question, guys, these questions are very simple. You just need to understand that this one, when you go on the periodic table, just passing through here, this is the symbol for bromine atom. So bromine atom, like this, bromine atom. So when you go to the periodic table, let me see if I have a periodic table here. Let me check this one I'm using. If I have a periodic table behind here. Okay, I seem to have a periodic table. Bromine, when you go on the periodic table, bromine has a symbol like this. Br, then here it should have 8, and then here it should have 35. Now, the important information which you need to know about an atom, this presentation of an atom like this, we call it nuclide notation. So in nuclide notation, we represent the atom in form of this, where this should represent atomic mass. This one represents atomic mass, which we also call mass number. That is what you should know. This is 8, guys. So this is 8. So 8 is supposed to be atomic mass or mass number. Then this value here, it is known as proton number. Proton number. Or you can also call it atomic number. Atomic number. So that this information is very cardinal if you want to understand chemistry. So in atomic structure, basically this is what you learn. If this is a symbol of an atom of bromine, then here the number which is placed here, it is atomic number. It is atomic mass or mass number. Then the number which is placed here is usually called proton number or atomic number. So some more information which we need to know is that this same atomic mass or mass number can be found by this formula. A is equal to, then we need to have Z plus N. So usually this A stands for what? Atomic number or mass number. You can give it as mass number, or it's the same atomic number. Then this value here, Z, is known as atomic number or proton number. So it can be atomic number, or we can call it mass number. Then N is neutron number. So we can call it neutron number. So this information is very, very important, guys, that you know this information here. So usually on the periodic table, they will put something there. There's a key already on the periodic table. There's a key which is written like this. Then here you might have Z, here you might have A. So this key is just there to show you that what they put here as a letter stands for the symbol or the chemical symbol for that particular atom or element. And then the value they put here stands for atomic mass or mass number. Then the value they put here stands for proton number or atomic number. So this is just a representation of what would be like this. So when you understand this representation or roadmap, it can help you to interpret this information there. So now, having known that, if you are given, for instance, okay, the other information that I need to give you that you need to understand here is this, that this atomic number is also equal to number of electrons. Number of electrons in a neutral atom. In a neutral So when an atom is neutral, that means that if it is a single, it hasn't reacted with any other atom, then the number of protons or atomic number should be equal to the number of electrons in an atom. So this is very important because having known this information, we'll use it to answer this question. Now, here we don't have bromine like this. We have what we call bromine ion because it has a charge here. So if it has anything having a charge here, it means this charge is just 1. We are supposed to put like this charge is supposed to be like 1 and the negative there. But because it is 1, we just don't include the 1, we just put the negative there. So what that simply means is that in an ion like this one is an ion because it has a charge. So it is an ion of bromine atom. So since it has a charge, what that means by negative charge, it means that now the number of protons or atomic number is no longer equal to number of electrons. It means in bromine, there are more electrons than protons or atomic number. So how many more electrons are there in bromine ion than bromine atom? 1. So this simply means there is actually 1 more bromine electron added to it than you would have. So in a neutral bromine, the number of electrons is always 35. Because atomic number, this 35 represents proton number or atomic number, which should be equal to that. Now, in a bromine ion like this one, this minus, it means bromine has gained 1 more electrons. So the number of electron here should be now 35 plus 1, so here it will be 36. That is what you should know. Negative means bromine gained 1 more electron. So when you come now in this question, we need to complete the table below. So here we have something has been placed there and here, and now here it is blank. So they want us to fill in here number of electrons in 1 particle of bromine ion. So this is the one we have found here, 36. What has helped us? It's this negative. It means that in a neutral we should have 35 now. Because there's a negative, it means we add one more. So here 36 as the answer. Then we come to symbol of an atom or ion. Here we have not been given the symbol, but here we have been guided, we have been given the proton number or atomic number of this particular atom here. And then we have also been given the number of electrons of this atom here. So what will help us to identify this atom here? Here, it is the number of protons here. So these questions are simple because in an exam there is also a periodic table. So you just go to the periodic table and locate something which has 11 here. So when I go to my periodic table, I'll locate something which has 11 down there. So on my periodic table, let me just remove this. So on my periodic table, I've seen that the one which has 11 down here is sodium, which is written like the sodium atom. Let me just remove this part here as well. So this one is sodium atom, which is written like Na. And down here there's 11, then down here there's 23. You have seen that? So now, the one which has 11 here, if you check equally you at home, check your periodic table. If you have it, you discover that this one is actually 11 is for sodium. So if now they want you to complete here, put the symbol for. But before you do that, you check also number of electrons. So number of electrons in a neutral atom of sodium, the atomic number, this number which is down here 11, which is also called atomic number, should be equal to number of electrons. So here number of electrons, if here we have atomic number 11, even here we are supposed to have 11. Now because we don't have 11, what has happened is that for electrons to be 10, it means one was lost. For electrons to be 10, one was lost because initially they were supposed to be 11 as well. So meaning one was lost. So if one electron was lost, now instead of you writing like we did here now in real sodium, the number of electrons should be 11 in a neutral sodium. Now here we see that the number of electrons is 10. So now what has happened? What has happened is that one electron was lost to reach here. So the symbol here now must be plus. If one electron is lost, then you put plus there. So meaning the symbol that you are going to put here is sodium plus like that. Okay? I hope this guys is making sense. If it is doing so, let me know in the comment section, and also give this video a like if you are watching from my TikTok profile or my Facebook profile or my YouTube channel profile. Give this video a like, follow me, subscribe, and also give this video a like, and also share with the others. Okay, so now let's go to the other one. So we have calcium. This is calcium. This is the symbol of calcium, and it has plus 2 or 2 plus. 2 plus meaning that it had actually lost 2 electrons. Now we need to fill in here what is going to be number of protons in one particle of calcium. Now what you must know is that protons are found in the nucleus of an atom. Therefore, they can't be lost or gained. They are intact. So, for us to know the number of protons for calcium, we'll just go to the periodic table and look for calcium. So the periodic table is always given. So calcium, the number of protons is 20. So if you go to the periodic table, you'll find that for calcium atom, which I'm writing for you here, calcium, like that, you'll find that the symbol here, let me rub these things here, it will be capital Ca. Here it has 20, then here it has 40. So this is what they're looking for, number of protons, because this number is proton number or number of protons. So when you go straight to the periodic table, you'll find it. So no need to stress, you find it on the periodic table. So put it 20 there. Yeah, so these things you don't need to stress. The periodic table is provided in the paper. So such questions, when they come, count them as bonus questions. We don't need to stress about them. They are bonus questions. So now, when you answer like that, you are done. Huh? I think we are done. Yes, we are done. So we are done with this one. Let us go to B. B, we are taught magnesium atomic number is 12. So magnesium atomic number is 12, has electronic configuration of 282. Has electronic configuration of 282. So before we go any further, I would love to explain electronic configuration. Electronic configuration. Remember, I've talked about the electrons. If you know the atomic number, then atomic number, also known as proton number, also known as atomic number, that is also equal to number of electrons in a neutral atom. So if we are told that magnesium atomic number is 12, we must also know that magnesium has 12 electrons. Now, when they talk about electronic configuration just means, it just talks about arrangement or placement of electrons in shells. Because these electrons we are talking about are placed in shells of atoms. So this is how they are placed. If magnesium has 12 electrons, how do these electrons sit in shells? So these electrons sit in shells. The first shell accommodates 2, the second shell accommodates 8, then the last shell should accommodate 2. So if you total them up, 2 plus 8, 10 plus 2, 12. So this follows atomic structure rules. So for you to do this, you must follow some atomic structure rules which guide on how electrons are placed in shells. So the first rule says that the number, in fact, we use a formula. Let me not talk about the rule as such. There is this good formula which we use. So we do it like this. Maybe let me put it this way. I have to teach you something, guys, for you to be one of my followers. I think you have just to know these things. So this is the formula which we use. Any number of electrons is equal to 2 n to power 2. So let me just explain what. I'm using this Ne to represent the number of electrons. Number of electrons in a shell. Then I can use N, just N here represents shell number. Yeah, I'll say shell number. So this formula is very important because it helps us to know how to distribute electrons in shells. Like if you have 12 electrons for magnesium, how can we distribute these electrons in shell? So we'll ask ourselves how much shell number 1 should we get of the 12 electrons. So shell number 1 means n is equal to 1. So you just replace here. You say equals 2 times, where there's n, put 1, then to power 2. Then you say equals 1 to power 2, 1, 1 times 2, 2. So this simply means number of electrons will be in shell number 1 will be how many? Should be equal to 2. Then if you want to know number of electrons in shell 2, you just get the same formula. You say, okay, number of electrons will be equal to, you get this 2, put it here, times this 2, you put this 2 here. This n, you put 2 there, then to the power 2. Then you say equals, then you say 2 to power 2, 4. 4 times 2, 8. So you have 8 here. So this is the number of electrons. Therefore, you say in shell number 2, it should have 8 electrons. Then, if you want to know how many electrons will be in shell 3, you should put shell 3 here. Then the same formula, you pick it, you say n is equal to 2, this same 2, you drop it, then times n, you put 3, 3 to power now 2, then you say equals 3 to power 2, 9, 9 times 2, 18. So shell number 3 is supposed to have 18, and so forth and so on. Now, this is the maximum number. So shell number 1, according to the formula, the maximum number of electrons it should have or accommodate is 2. Then shell number 2, the maximum number of electrons it should accommodate is 8. Then shell number 3, the maximum number of electrons it should accommodate is 18. However, there are some exceptions which we say if you do not have enough electrons to make it up to 18, you can also give it 8. So 18 or 8. So that is an exception. So if the number of electrons left out as you are distributing electrons, you cannot get 18, but you can get 8. Then you can give shell number 18 8. I mean shell number 3 8 electrons, and that would be as well stable. Yeah. So having at least given you this background, we can now look at the question here. The question here says, in the same way, state the electronic configuration of potassium atomic number 19. Okay, potassium atomic number 19. So, in the same way, for magnesium, its electronic configuration was placed like this, like 2, 8, because it has 12. So 2 went there, you start distributing. So when you get 2, you put there. From 12, you remain with 10. Then from that 10, you get 8, you put there. So you remain with what? 2. So 2 remains there. So for potassium as well, you have 19. So what you are going to say for potassium chem, its electronic configuration, you are going to say the first shell should have 2. Okay. Then from 19, you remove 2. You remain with what? 17. So from 17, you know that the second shell should have 8. So from the 17 you are remaining with, remove 8, put here. Okay. So once you remove 8, you put here, what are you going to remain with? You remain with 9. Okay. So this shell number 3, shell number 1, number 2, number 3 should have 18. But how many more electrons are you remaining with? You are remaining with 9. Therefore, you should give it 8 which is the second option I talked about. So from that 8, when you remove, from that 9 remaining, when you remove 8, you place here, you remain with 1. So 1 will be placed in this shell here. So this will be the electronic configuration for potassium. So when you total these, they should give you 19. 2 plus 8, which will be 10. 10 plus 1, 8. 18. 18 plus 1, 19. So this is the electronic configuration for potassium. So we move to the second question, which is saying, in what period of the periodic table is potassium found? It's a very, very good question, guys. In what period of the periodic table is potassium found? So this one, you can answer it directly by checking the periodic table. So on the periodic table, except that these are very small, you can't see this pamphlet I'm using. So these horizontal rows are known as periods, and these vertical columns are known as groups. So the first one, this is period 1, this is period 2, this is period 3, then this is period 4. So when you check, potassium is somewhere here. It is in period 4. However, you see, so the periodic table is also there in an exam, but we can also get this answer from here. So you can know that it is in period 4. These are free marks, but also you must know that the number of shells an atom has is equivalent to the period in which it is. Okay, so it has how many shells? Shell 1, shell 2, shell 3, shell 4. So the number of shells an atom has is equal to the period in which it belongs. The number of shells an atom has is equal to the period in which it belongs. So since it has how many shells? 1, 2, 3, 4. Therefore, potassium is in period what? 3. So when they say in what period of the periodic table is potassium found, you can say period 3. You can forget like that. Then part 3 says, write the formula of potassium in an ionic compound. We write the formula of potassium in an ionic compound. So in chemistry, it's very also important to know the formula. A formula in chemistry, in terms of a compound, it is just the symbol. The symbol. So formula is a symbol. So we know potassium, its symbol on the periodic table, if you go potassium, its symbol on the periodic table, symbol is what? K. That is its symbol. Now, because they are saying we find its formula in an ionic compound, meaning that when potassium reacts to form a compound, give us what? The formula. That's what they're saying. So potassium, when it reacts, when elements are reacting, elements react to form compounds that are stable. So what does it mean to form compounds that are stable? If a shell has not accommodated the maximum number of electrons required, like in this case, this shell, last shell here, shell number 4, is accommodating 1 electron. It's supposed to have 8 or 36 somewhere there, if not mistaken, but it has 1. So such a shell makes this atom of potassium not to be stable. Therefore, whenever potassium is reacting, it has to lose this electron here, so that If it loses electron, the configuration changes for potassium. Since potassium loses one electron here, here you put plus. Then here you write 2, 8, again 8. These electrons has been lost. So this way, potassium has become stable because the last shell number 3 now it has 1, 2, 3 shell. Shell number 3 has at least the required number of electrons in the last shell. So like this is what potassium does whenever it is reacting to form a compound. So if they want us the symbol for potassium in a compound, it will be the symbol. Let's write symbol or formula. They have used the word formula. So we'll also follow the same. So same. The formula for potassium, I'll just put this one, potassium in an ionic compound is what? Is this one I talked about, K plus. Just like that, guys, just like that. So this is how we answer these chemistry questions, guys. Okay, so if you want online tuitions, especially for those going for 2025 GCE, you can contact me on my WhatsApp number 0977 92 41 75 1977 92 41 75. Then for those that would want to have the revision package for science in videos, where I've revised past examination papers in videos, you can also WhatsApp me on the same number 0977 92 41 75. The revision package for science is going at a promotion price of 120 kwacha. So these revisions are videos where I've explained how to answer examinations questions from 2015 to 2023. Okay, so guys, for now, bye and see you in the next video. Peace.